Hello, hi everyone. Welcome to this Tune the Brand. This is your Shiva sir. Today we are going to discuss about scalars and vectors. Scalars and vectors. So let's start. Scalars and vectors. Here you can observe. Here you can observe scalars and vectors. When you go to shop, so if you ask, I want rice, will you give immediately? So if you go to one more shop and ask, I want chocolates, will you give again? So no, he will ask questions. He will ask questions. So what are those? For how much you want, and how many you want. So if you see rice, how many kgs you want, for how much you want, like that he will ask, right? You will ask two questions. Yes or no? You will ask two questions. So the answer for how much or how many is called quantity. That is nothing but amount or vastness or magnitude. Okay. So magnitude. That is called quantity. So like 2 kg, 3 kg, like that. And the quantity which can be measurable, is called physical quantity. The quantity which can be measurable is called physical quantity. Understood? So there are few are there, like the quantity which can be measurable, like mass, speed, velocity, acceleration, weight, like this. Okay, the quantity which can be measurable is called physical quantity. There are three types of physical quantities are there: fundamental physical quantity, supplementary physical quantity, and derived physical quantity. Coming to the fundamental physical quantity, so these are basic quantities. These are basic quantities like LMT star, length, mass, time, strength of electric current, amount of substance, thermodynamic temperature, and luminous intensity. Like this. And one more thing, supplementary physical quantities: plane angle, solid angle, and derived physical quantity, the quantity which can be derived from the remaining physical quantities. Those are called derived physical quantities. Understood? So I hope it is very clear. Next, we'll go to the concept of scalars and vectors. Our main topic is scalar and vector. We have to discuss about it. Our main topic is scalar and vector. So we will discuss about scalar and vector. Scalar and vector. Okay. So what is scalar? The quantity which has only magnitude. Physical quantity which has only magnitude is called scalar quantity. So physical quantity which have both magnitude and direction. Physical quantity which has both magnitude and direction, that is called vector quantity. Understood? Scalar and vectors. Scalar and vector. Okay. Let's start the topic. So briefly, now you can see scalar. Coming to scalar, the physical quantity which has only magnitude, that is called scalar quantity. The physical quantity which has both magnitude and direction. Magnitude and direction. Okay. So the physical quantity which has magnitude and direction, that is vector quantity. The physical quantity which has only magnitude, that is called scalar quantity, right? So now we will discuss about types of vectors. We'll discuss about types of vectors. Let's start. Types of vectors. Types of vectors. First one is equal vector. So types of vectors. So first one is equal vector. Second one is negative vectors. And coming to third one, equal vector, negative vectors, collinear vector, coplanar vector, null vector. Okay. So I am taking zero vector, zero or null vector, and coming to third one, unit vector. Okay. So fourth one, unit vector. So and fifth one, orthogonal unit vectors. Orthogonal unit vectors. And coming to the co-initial vectors. And seventh one, collinear vectors. And coming to eighth one, coplanar vectors. And ninth one, localized vector. And coming to 10th one, non-localized vector. Or free vectors. Non-localized vector or free vector. Understood or not? So coming to the first one, equal vectors. Equal vectors are nothing but, so the vectors magnitude and direction both are so equal magnitude, at the same time both are acting in the same direction. So two vectors having equal magnitude and acting in the same direction. Okay, so those are called equal vectors. Coming to negative vectors, so if you are taking here, so vectors having equal magnitude but acting opposite direction. Coming to zero vector. Zero vector is nothing but the vector whose initial point, okay, the vector whose magnitude, the magnitude of the vector is 0. Then we can say zero vector or null vector. Coming to unit vector, the vector whose magnitude is 1. A cap equal to A bar by mod A bar. Coming to orthogonal unit vectors. So the unit vectors acting along the orthogonal axis. So unit vectors, if you are saying, so if you take unit vectors I am taking, so along x-axis, y-axis and z-axis. Along x-axis I cap, along y-axis j cap, along z-axis k cap. Okay. So I cap, j cap, k cap are the unit vectors are acting along x-axis, y-axis and z-axis. X-axis, y-axis and z-axis. Understood or not? So those are the unit vectors are acting along the orthogonal axis. Coming to co-initial vectors. So what do you mean by co-initial vectors? the vectors initial point is same. So A bar and B bar, A bar and B bar. Understood or not? And so this is the angle you can take. And collinear vectors are nothing but the vectors are acting in the same line. So if you are taking this one vector, one more vector are acting in the same line. Coming to the coplanar vectors. Coplanar vectors are nothing but the vectors having, okay. So vectors are acting in the same plane. Vectors are acting in the same place. So if you are taking x-axis, y-axis, z-axis, xy plane, yz plane, so zx plane like this. So vectors are acting in the same plane. Those are called coplanar vectors. Coplanar vectors. Coming to localized vector. Localized vector is nothing but the vector whose initial point is fixed. The vector whose initial point is fixed, that is called localized vector. Coming to non-localized vector, the vector whose initial point is not fixed. The vector whose initial point is not fixed, that is called non-localized vector. Non-localized vector. I hope it is very clear. Once again, so equal vectors. So vectors having equal magnitude and at the same time, those are acting in the same direction. Coming to the negative vectors, equal magnitude. So two vectors having equal magnitude but acting opposite to each other. Means so opposite direction. Both are having opposite direction. Coming to the zero vector, the vector whose magnitude is zero. The vector whose magnitude is zero, that is called zero vector or null vector. Coming to the unit vector, so the vector whose magnitude is 1. The vector whose magnitude is 1, that is called unit vector. So A cap equal to A bar by mod A bar. Coming to orthogonal unit vectors. So I cap, J cap, K cap are the unit vectors acting along x axis, y axis, z axis respectively. And coming to the co-initial vector. So the vectors whose initial point is same. And collinear vectors are acting in the same line. Okay, coplanar vectors are acting in the same plane. And a localized vector whose initial point is fixed. Non-localized vector, so whose initial point is not fixed. So these are the types of vectors. Okay. So next one. So we'll discuss about addition of vectors. Addition of vectors. Okay. There are triangle law vectors, parallelogram vectors, polygon law vectors. Understood or not? Let's start. Triangle law vectors. So you can check here. Triangle. Addition of vectors. Addition of vectors. Okay, so point number one is coming to addition of vectors. Point number one, we can take triangle of vectors, parallelogram vectors. First one is triangle of vectors. Second one is parallelogram law of vectors. And the third one is so polygon law of vectors. Understood? Polygon law of vectors. Coming to triangle of vectors. Okay. So triangle of vectors, we'll discuss about triangle law. Triangle of vectors. Triangle law. So triangle law, if you are taking triangle law of vectors. Triangle law. So triangle law of vector. So in addition, so this is a triangle law of vector. Very, very important. Very, very important. Just observe here. Observe when two vectors are acting along the two sides of the triangle. So I am taking, this is one side A bar, this is A bar, and another side I am taking B bar, and the resultant you are considering opposite. So you have to take opposite to the these two vectors, opposite to the first two vectors, that is the resultant vectors. Okay, so here you can observe. So the resultant will be acting opposite of these two vectors. So this is A bar and B bar, the remaining is C bar. Understood or not? So A bar, B bar, C bar. So A bar is acting so along the side of the triangle, and B bar also. These two vectors are acting along the two sides of the triangle, and the resultant will be the opposite to the both two vectors. Okay, so here you can observe C bar equal to A bar plus B bar. Okay, so I'll draw one more diagram. Just try to identify the resultant. So here I'm considering, so this, so this is A bar and C bar and B bar. So now you can tell me which one is the resultant. Here A bar and B bar acting in the same direction like this. So but C bar is acting opposite direction. Opposite direction. So A bar and B bar are acting in the same direction, but the resultant will be acting opposite direction. Understood? That is C bar. So then we can say A bar plus B bar equal to C bar. Understood? So that's enough. Soon we will discuss. This is a triangle of vectors. Coming to the parallelogram of vectors. Parallelogram law of vectors. Parallelogram law of vectors. Parallelogram. Parallelogram of vectors. So you can observe here parallelogram of vectors. So two vectors are acting at same point. So two vectors are acting at same point, and at the same time acting along the two sides of the parallelogram. Two vectors are acting at same point at the same time. Those vectors are acting along the two sides of the parallelogram. So you can see here, this is one side and this one is another side. So I am taking this is the A bar and B bar, and the resultant is the diagonal of these two vectors and acting at the same point. So I am taking this is one side and this is one side. So opposite sides are equal. So I am taking this is A bar and B bar. So the angle between A bar and B bar is theta. The angle between A bar and B bar is theta. Okay, so here you can observe. So then I am taking this side like this also angle theta, and I am taking this is x and y. So y along the x axis. So parallel to the x axis and parallel to the y axis are there. So that's why I am taking x and y. If you are taking this the triangle, so this triangle if you are considering this one, so this is x, y, and this one is b. Okay, so angle is theta. Now from this triangle, so what is cos theta? Cos theta equal to adjacent side by hypotenuse. Adjacent side by cos theta equal to adjacent side by hypotenuse, x by b. Then x equal to b cos theta. X equal to b cos theta. Coming to here, sin theta equal to opposite side by hypotenuse, that is y by b. Then y equal to b sin theta. Y equal to b sin theta. So x equal to b cos theta, y equal to b sin theta. X equal to b cos theta, y equal to b sin theta. Understood or not? So if you want the resultant, this is a resultant vector. So acting diagonal to A bar and B bar. Now if I want to find out resultant, so hypotenuse square equal to side square plus side square. Hypotenuse square equal to side square plus side square. That's why R r square equal to, so this is a plus x. So a plus x whole square plus y square. Hypotenuse square equal to side square plus side square. Hypotenuse square equal to side square plus side square. So that's why r square equal to here. So a plus, so what is the x value? X value equal to b cos theta. X value equal to b cos theta. So a plus b cos theta whole square plus y square how much? B sin theta. B sin theta whole square. Understood? So now we know a plus b whole square formula. A plus b whole square formula is a square plus b square plus 2ab cos theta. So a plus b whole square formula is a square plus b square plus 2ab cos theta. I hope it is very clear. So now you can see here. So now you are getting this one. Whatever you are getting, a square plus b square plus 2ab, a square plus b square plus 2ab. So here we will get here with that. So r square equal to a square plus b square cos square theta plus b square sin square theta plus here 2ab cos theta is there, right? 2ab cos theta. Now r square equal to here b square theta plus b square theta. Normally sin square theta plus cos square theta equal to sin square theta plus cos square theta equal to 1. Sin square theta plus cos square theta equal to 1. Now here you can take a square plus b square you are taking, then sin square theta plus cos square theta equal to 1 plus 2ab cos theta. 2ab cos theta. So that is the remaining r square equal to a square plus b square plus 2ab cos theta. So here I wrote 2ab cos theta like that. Okay, done. If you are taking r equal to root over a square plus b square plus 2ab cos theta. So this is the resultant. This is the resultant. One check. So everyone check the concept. Check once. Is it clear? Okay. So next one. Okay, next one, polygon law of vectors. So now we discussed about completely parallelogram of vectors. Now we'll discuss about polygon law of vectors. So let's see. Polygon law of vectors. Polygon law of vectors. So now you can observe I am considering the vectors along the sides of the polygon, then the resultant will be opposite sides of the all the vectors. So if I take A bar, B bar, C bar, D bar and E bar, and F bar is the resultant, it is acting opposite to all the vectors. Okay, so that is a resultant. Resultant vector will be acting opposite to the side of the all the vectors. So F bar equal to A bar plus B bar plus C bar plus D bar plus E bar. Okay, so just like triangle of vectors, just like triangle of vectors. I hope it is very clear. So this is about it is about polygon law vectors. So coming to the product of vectors, product of vectors. Okay, product of vectors. So we'll discuss about product of vector. There are two product of vectors. So product of vectors. One is dot product. One is dot product. Dot product or scalar product. Dot product or scalar product. Scalar product. Second one is cross product or vector product. Vector product. Okay, so dot product. So what is dot product? So dot product is nothing but the product of two vectors. So A bar dot B bar. The product of two vectors is equal to product of their magnitude and cosine angle between them. So dot product. So dot product or scalar product. So you can see dot product. So if I am taking A bar dot B bar, A bar dot B bar, that is nothing but A bar AB. So AB product of their magnitudes and cosine angle between them. Suppose if I am taking A bar equal to 2i cap plus 3j cap plus 4k cap and B bar equal to, so A bar so okay, so instead of taking values, so I'll take x and y, so then we'll get, okay. So simply if you are finding the magnitude and cosine angle between them, we can find out. Even if you want to find out same thing also fine, no problem. So 3k and 4k, and even I'm considering, so here if you are taking directly 4i cap 6j cap plus 3k cap. So now A bar dot B bar. A bar dot B bar directly you can multiply. So I cap and I cap, so much 4 2 8 plus 18 plus 12. How much? So 38 is the answer. So we are getting magnitude. So we are getting the magnitude. So if they give angle also we can find out. So by multiplying this one and find out the magnitude, so you can take this one. Understood? So likewise you can solve this question. So I hope it is very clear. So any doubts? Right. So next one. Dot product. Coming to the scalar product. So this one is scalar product, right? Next vector product. Vector product. That is nothing but cross product. Cross product or vector product. Cross product or vector product. Vector product. Vector product. Okay, so here now A bar cross B bar, that is nothing but AB cos sin theta, right? Sin theta. So magnitude, product of their magnitude and sine angle between them and n cap. So it is a vector product. Okay, so if A bar and B bar, then n A cross B cross A. So this A bar B bar. The resultant is like this. Okay, that is n cap. That is nothing but A bar cross B bar. Okay, so A bar cross B bar. I hope you can understand. So like that, A bar equal to I cap, 3j cap, 4k cap. So B bar equal to 6i cap, 7j cap, 8k cap. Then you can take I, j, k. So write all the values, you can do it. So we'll do based on this one, few more problems we'll do based on dot product, cross product. So in the next class, so in the one more class, we'll discuss more points. Thank you so much for joining and attending and listening. Do like, share and subscribe to Student the Brain. Thank you so much.